Okay, so now we have calculated the total resistor. In fact, we reduced the circuit step by step. We are now in a position to solve for all the currents. The first thing we'll do is find the total current. And the total current would be, of course, the total supply voltage divided by the total resistance. And that gives me, so IT is equals to Vs over RT, which is equals to 100 divided by 9.60 amps. That gives me 10.42 amps. Now here's the neat thing about this. From now on, we actually could go and put in all the currents in all the various circuits. So that 10.42 amps is coming out here. That's IT. I can put it at every stage. It's not necessary to put it at that one. I'll put it here. IT equals to 10.42. And I can go all the way and put it to the top. So that's the current coming out of the battery. IT is equal to 10.42 amps. Now, you see how that's working. As we find a current, we put it in the solution circuit. We may find it useful to put it in the various other circuits also, but I want to rush ahead with the solution. So next, I'm going to solve this second circuit here. I want to find the current going through this 6 ohm resistor, which is the R2. So I want to find this current, which I'm going to call I1. That current, which I'm going to call I2. Now, sometimes it's useful to label the currents consistent with your resistors, but we will find ourselves in the trouble if you do that. So we can just invent a new naming system, I1, I2 there. Now, pro tip. Notice we have here the main current is splitting into 2 branches. This gives us an opportunity to use something called the current divider rule. So the current divider rule this is when we have one current is being split into 2 branches like this. Let's call that R1, let's call that R2. That's the current IT. And we want to find what's I1 and what's I2. So the current divider rule is a simple shorthand system of finding these various currents. So we'll say that I1 is equals to IT times R2 over R1 plus R2. And similarly, I2 is equal to this IT times R1 over R1 plus R2. Notice this and this. They're not the same. Similarly, notice this and this. They're not the same. Okay, so my I1 is, my IT is 10.42. And my R1 and R2 is 6 and 19.78. So let's go ahead and apply that rule. Let's do it on this side. So let's say I1, that's I1 coming down here, is equal to 10.42. I think I crowd myself up there. So let's pause. Yeah. So let's go and find I1. And that's equals 10.42 times R2. Now, that means the other resistance times 19.78 over 6 plus 19.78. Putting that quickly in my calculator, I get 10.4 times 19.78 divided by 6 plus 19. I'm getting approximately 8 amps going here. 8 amps. And I can do two things. I can subtract 8 amps from 10.42, or I can apply the formula. I'm going to apply the formula just so you can see how it works. So let's go find I2, and that will be 10.42 times, this time is 6 over 6 plus 19.78, and that is 2.42. Now, on the side note, 8 plus 2.42 is 10.42, which is what we expected, right? So I could go and write in these currents now. I could write it in here that I1, this is equals to 8 amps. And on this side, I have 2.42 amps. I'm gonna put that. So this is my 8 amps, and this is my 2.42 amps. Now this current flows through REQ1 2.03 ohms. It also flows through this REQ6, which is 5.75, and it flows through this 12. So I can take the opportunity immediately to go and find the voltage drops across each of these branches. So this voltage here, I'm going to call that V2, and that equals to 2.42 times 5.75. 2.42 times 5.75, and that is equals to 13.94 volts. Across this 12 ohms, same thing. Actually, I have the R in the wrong place. $12 multiplied by 2.42. So this voltage, V, let's call it 3, is equals to 12 times 2.42, and that will give me 29.1 volts. And I can say the same thing here. That's V3. V1. V1 is equals to 2.03 times 2.42, and that will give me 4.92 volts. 4.92 volts. So I will now transfer these voltages onto the higher circuits. By the way, I can similarly go and find this voltage right here. This voltage, I can do that mentally in my head, 8648 ohms, 48 volts. So let's go put these voltages in this new circuit. We know this voltage is 48 volts. I just found that the voltage across RAQ6 is this 5.75. Remember how we got this 5.75? It was these two resistors I worked. So I know the voltage across here is 13.94 volts. 13.94 volts. Now make sure you understand how did I get that to be there. Okay, remember it is the two resistors in the circle there that was combined to give me that 5.75. So it means the voltage across the parallel branches is common, so 13.94. Now I can use this information immediately to go and find the current coming down here. This current and that current. Now I already have I1 and I2, so I'll call this I3 and I'll call this one I4. Now I can go and find it immediately because, why? The voltage across this resistor is 13.94 and the voltage across this resistor is the same 13.94. So I can say I3 is equals to 13.94 divided by 9.32, and that's amps, and that'll give me something. I'll go to my calculator and get it just now. I can also say that I4 is equals to 13.94 divided by, what's that, 15 ohms. Putting these things in my calculators, I get divided by 9.32 equal, I get this is equals to 1.4 1.49, really 1.5. Let's call it 1.5 amps. And the other one is 13.94 divided by 15. And I get 0.93. So I can go immediately write them in. I3 is equals to 1.5 amps and I4 is equals to 0.93 amps. Alright, so we now found I3 and I4. We can leave I4 as it is for the moment, and let's concentrate on I3. Now I3 is passing through 9.32 ohms. But remember that 9.32 ohms was really a combination of 5.42 and 3.87. So we know the current now flowing through these two resistors is 1.5. So that allows me now to find the voltage across each of these resistors. So this one and this one. Okay, so going back to my naming and numbering, the last voltage I had was V3, so I'll call it V4 and V5. So this is V4 and this is V5. So V4 is equals to 5.45 times, what is the current passing through there again? 1.5. And that will give me something. And V5 is equals to the same 3.87 times 1.5. Again, going to my calculators, I have 5.45 times 1.5, that's 8.2 volts. And V5 is 3.87 times 1.5, and they give me 5.8 amps, 5.8 volts. Okay, so now I can, let's put these in. This is equals to 5.8 volts, and this is equals to 8.2 volts. Now, same idea. Remember REQ2, that 5.45 was a combination of several resistors, and the 3.87 was a combination. Let's go and see what combined to give what. So right here, I know that these three resistors was what combined to give me 3.87. So the voltage there must be 5.8 volts. So the voltage across these three resistors, remember all parallel branches carry the same voltage. So I know this voltage here is 5.8 volts. And I know the voltage across this branch is that value that I found there, 8.2 volts. Now, since the voltage across parallel branches are the same, I can use that voltage to find the current in each of these resistors. So I'm going to start with this one. What was the last name current I used? I4 and I5, so I'll go with I6 and I7. So I'll call this one I6. I'll call this one I7. I'll call this one, and let's put it here, I8. Remember, it's I8 coming down here also. I'm in a position to find these currents. So let's go and find each of them. We'll say that I6 is equals to 5.8 volts over 8 ohms. I7 is equals to the same 5.8 volts over 12 ohms. And I8 is equals to 5.8 over 20. So putting these in my calculators, 5.8 divided by 8, 0.73 amps. This one is equals to, divided by 12, 0.48 amps. And this one is divided by 20, 0.29. Okay, we can write it in, but I want to jump over to this 10 and this 12 ohms. I just found out the voltage there is 8.2 volts, so I can call this current I9 and this one I10. So continue along the same pattern. I9 is equals to 8.2 volts, 8.2 divided by 12, and I10 is equals to 8.2 divided by 10. Okay, that's 0.82. I know that immediately. But this one I'll have to calculate. 8.2 divided by 12. 0.68. So you see, we now can backtrack up and find all the currents for the various circuit. We already know what's the current coming down this 5. We already know what's the current coming down this R6. I think we found that to be 8 amps. Let me see. No, we found that to be, yeah, 8 amps. Look, it's right there, R6. So we can write that in. This we know is 8 amps. Oops. This we know is 8 amps. Okay, what about these three here? Remember, we found the voltage between A and B. We found it to be V1, which is 4.92. Was the voltage here, 4.92. So if you know the voltage across this entire branch, is 4.92, the voltage across this entire branch is 4.92. We can find the current in each little bit. I'll leave you to do that. We also found the current across this bottom branch here. When you go look at it, you'll see again that we found the voltage across this bottom branch, and you can find the current in each. Okay, we already found the current going down this 16, and if you add up all those currents, we should get whatever's coming out here. Whatever's coming out here is what's going in there. And that way we can proceed to solve for the entire circuit. Okay, so I went ahead and put in all the currents we knew so far. These are the currents we found. We found 0.82 through the 10 ohm resistor, 0.64 through the 12, 0.73 through the 8, 0.48 through the 12, and 0.29 through the 20. I had 0.93 coming down here. I had 8 coming down here. Now let's go ahead and find the current flowing through this first parallel branch. And notice the voltage again is common. It's common, so I'll find this current. I'll say I is equals to V divided by R. I wouldn't write that. So 0.62 through the 6 ohm resistor, 0.82 and through that 8 ohm resistor, 0.62, 0.62. Well, we have 2 8 ohm resistors there, so we expect to be the same, going to be the same. 0.62 amps. At the bottom here, 20 and the 30, we know the voltage is 24.1 volts, 29.1 volts. So we divide, to find current, divide voltage by resistance. So the current here will be 29.1 divided by 20, and that'll give me 1.46. 1.46 amps. I have the arrow the wrong way. Arrow is this way. Let me get that right. The arrow is supposed to be this way because the current is going around clockwise. 0. So that's 1.46 amps, and the current there is divided by 30, 0.97, 0.97 amps. This 0.97 combined with that 0.46 combined with this 8 should give me 10.42. So the current going up here is 10.42. And of course, the voltage across this 5 ohm resistor is that current multiplied by 5. 10.42 multiplied by 5 will give me 50 something. 52.1. So there you solve the circuit. We found every current and voltage that is required. Now there are various methods and tips, but that's a systematic method. And this had quite a bit of resistance in it, so they have many bits of current to find. Now once you know the current and once you know the voltage or the resistor, you can find the power. But this is the strategy for solving a circuit. So let's recap. First you find the total resistance, and then you work backwards. As you work backwards, you fill in the values that you know. So we first found RT, and we were able to fill in RT for the bottom here. RT to be 9.6, and we were able to find the current is 10.42. From that current, we were able to find the voltage across 4.06. Now remembering that 4.06 is a parallel combination of these two resistors in the circle, but the voltage across parallel branches is the same. So using that knowledge, I was able to find the current I1 and I2. Now that 19.78 is really a series combination. So I know that 0.42 is flowing through all the elements in a series circuit. So 0.42 is flowing through our 2.03 is flowing through 5.75. It's also flowing through this 12. So multiply that current by the resistance, I get each of the respective voltages, which I have here. Now, why do I need that? Because I know the voltage, for example, that 5.75. That 5.75 is really acting across is really a combination of several resistors. The 5.75 sorry, I should say that 9.2 is a combination of 2.03, 5.75, and what am I saying there? Sorry, I mix you up there. 9.73 is a combination of 5.4 and 3.87. So once I find the voltage across the 9.32, and that's voltage across also the voltage across the 50. I was able to find the current. Once I can find the current, I know this 3.87 is really those three resistors combined. So whatever voltage is across the 3.87 must appear across all three of them. Whatever voltage is across this 5.42 must appear across the 10 and 12. Similarly, whatever voltage is across this 12 ohm must appear across this 29.1 volt combination. So that is the strategy you'll use, and you solve the circuit. Now you have to practice